Anyway. Here's some 2017 for you. Night before Christmas, one of Santa's elves calls you in a panic. Printer's broken. Ugh. We can't print the naughty or nice list. By the time you make it to the sub-basement 17, there's only a few minutes until midnight. We have a big problem, she says. There must be almost 50 bugs in the system, but nothing else can print the list. Stand in the square, quick. There's no time to explain. If you can convince them to pay you in stars, you'll be able to... Okay. Oh, okay. So the whole... The big premise here is fixing a printer. Got it. Okay. Collect stars by solving puzzles. Right. Okay. Digitization quarantine written in LEDs along one wall. The only door is locked, but includes a small interface. Goes on to explain that you may only leave by solving a CAPTCHA to prove you're not a human. Apparently you only get 1 millisecond to solve CAPTCHA. Too fast for a normal human, but it feels like hours to you. CAPTCHA requires you to review a sequence of digits and find the sum of all the digits that match the next digit in the list. The list is circular, so the digit after the last digit is the first digit in the list. Okay. Oh, have I not authenticated? Hold on. I swore I had done this already. How have I logged in the past? My guess is probably Twitter. Yes, it is Twitter. Python. I know, I technically know a lot of languages, but Python's the only one I feel like doing anything in. I know you did. I can do this because of Python. Oh, that's cute. 1031. Python 3. You notice a progress bar that jumps to 50% completion. Apparently the door isn't satisfied, but it did emit a star's encouragement. The instructions changed. Now instead of considering the next digit, it wants you to consider the digit halfway around the circular list. That is, if your list contains 10 items, only include a digit in your sum if the digit... Yeah, 5 steps forward matches it. Unfortunately, your list has an even number of digits. Same input, right? Okay. How did I do this in the past? Trying to make sure that did I just like comment out the old version of it? What did I do?
Never give up.
Yeah, I guess so. Alright, whatever. If my clumsy solution worked for me last time, I'll do a clumsy solution again. Lauratia, thank you so much for the subscription. If the length is 2, and that'll be 1, and that'll work. Okay. The length is 10, that'll be 5, and that'll work. Right. I minus 5. Yeah, I think that'll work. I think the math works out on that. That seems like that should be fine. As you walk through the door, a glowing humanoid shape yells in your direction. You there! Your state appears to be idle. Come help us repair the corruption in this spreadsheet. If we take another millisecond, we'll have to display an hourglass cursor. The spreadsheet consists of rows of apparently random numbers. To make sure the recovery process is on the right track, they need you to calculate the spreadsheet's checksum. For each row, determine the difference between the largest value and the smallest value. The checksum is the sum of all of these differences. Hey Bob, that's a cute dog. Let me just make sure I can process the lines properly first. What's the standard way to split? It's just for line in input dot strip dot split on new line. I'm sure that's correct. I don't know why I'm blanking. Okay, so I get each line, and then there's my data. No. Hacking goes okay. Looks like we're on the right track after all. Here's a star for all your effort. Based on what we're seeing, it looks like all the user wanted is some information about the evenly divisible values in the spreadsheet. Fortunately, none of us are equipped for that kind of calculation. Most of us specialize in bitwise op. But it is a bit... Okay. sounds like the goal is to find the only two numbers in each row where one evenly divides the other, and that is where the result of the division operation is a whole number. They would like for you to find those two numbers on each line, divide them, and add up each line's result. There's no way, I mean, it's not enough data for me to need to do anything elegant. I'm just trying to think, is there like an elegant way to do this? Finding the two values that evenly divide each other. Is there like a really nice, elegant way to do that? Sure there is. I'm just not sure that I have in my brain a really elegant way to... Because, I mean, you can do it in n-squared time really easily, right? You sort the list, you start with the smaller values, and for each smaller value you try it against all the larger values, but... Is there a method that's faster than that? I'm trying to think if there's anything faster than n-squared for that. What would an n log n solution look like? An n log n solution would require you to be able to do some sort of subdivision of your data. I'm not sure that you'd be able to really easily subdivide that information. Huh. You actually could do this in linear time, couldn't you? Only if you could do fast factorization, you could do it in linear time. Right? If you could do some sort of quick factorization, you could probably do it in linear time. No, the way I'm thinking of it wouldn't work, actually. I don't think you could. I don't know. It doesn't really matter. The dataset's so small in this one that it's honestly trivial to just implement it. I'm just overthinking it for fun. Let me do it even clumsier. This is fine. 4x and data for y and data. X not equal y and x divided by y. Nope. Equals 0. Whatever. Don't care that much. Come across an experimental new kind of memory stored on an infinite two-dimensional grid. Each square on the grid is allocated in a spiral pattern starting at location marked 1 and counting up while spiraling outward. For example, the first few squares are allocated like this. Well, it's very space efficient. No squares are skipped. Requested data must be carried back to square 1. Location of the only access port for this memory system. By programs that can only move up, down, left, or right, they always take the shortest path, Manhattan distance between the location and data. Data from square 1 is carried 0 steps, square 12 is carried 3 steps, and so on, blah blah blah. Oh, that's a really fascinating problem. I love problems like these, where you have to discover the underlying structure. These are my favorite types of problems, because they're not, like, programming-wise, typically too tricky. I mean, I could be wrong, but they're not typically too tricky, but... So the question is from any given cell, I need to be able to identify... its X and Y coordinate. Right? Because if you know its X and Y coordinate, then it's trivial to implement. So the first... So I guess you can just first take the square root of the number and that'll tell you what spiral it's on. Is that right? Just take the ceiling of the square root? No, it's not square root, it's, I'm close. It is square roots, but it's a funny function. It's square roots, but it's only odd numbers, right? So, like, the outer spiral here is, like, if you take the square root of the number, if it's like the ceiling, but you're looking for the next highest odd number. And that'll align everything to the same spirals. What I need to do is I need to write a method that tells me for a given number its coordinates. And then I need to test it against like the first 25 values and confirm that it's working, and then I'll trust it for my actual input. Oh, I see how it works. Okay. Alright, bear with me here. So the 1 goes to right here. The next square, 4, is this square. Then 9 gives me this 3 by 3. And then 16 gives me this 4 by 4. And then 25 gives me this 5 by 5. Okay, you can start to really make a system here. Shut up. If even one of you InfoSec dweebs in my chat tells me that I should do a Windows update, we're gonna get into a fist fight. Right now. Every time Windows does an update, I have to reset up everything for streaming again. Sometimes I just don't have the brain space for it. I'd prefer the observations to be kept to a minimum, I don't know. I don't like doing the advent calendar as their release, just because I don't want to work on one problem and then put it down. I typically I don't have the mental energy to do things that I'm not streaming for the most part. Like, streaming is my way of making myself focus on something, and so if I'm going to stream it at all, I want to be able to stream like 10 of them. I want to stream like working on 10 problems. I feel like, I mean, it's totally possible that I'm overthinking this, but I'm trying to see if there's like a really easy mathematical way to work through this one. Oh, wait a second. Oh, hold on. Oh, that's so elegant. Each of the squares is actually the square root of that number minus 1 away from where it needs to go, right? So 4 is 1 square away. So the square root of 4 is 2. Minus 1, that's 1. 9, the square root of that is 3. It's 2 tiles away in Manhattan distance, so 1, 2. 16, square root of that is 4. Minus 1 is 3. It's 3 steps away. That's kind of elegant. That holds for 25, right? It's 1, 2, 3, 4 steps away. That's nice. What's 2, though? I didn't say 23, I said 25. 25 would be right here. And it's 1, 2, 3, 4 steps away. So, I mean, that's an observation, but how do I use that? Is there, like, some really obvious thing I'm missing where it's like, you just always know if you go right, you get this. If you go up, you get this. It's like, there's gotta be some really simple thing I'm missing. I bet there is. And I bet I'm gonna find it too. I'm almost certainly over-engineering this, but I'm fascinated by the problem, right? Because I could very easily just enumerate all the locations up to 277,000. Like, so trivial to just, like, draw the spiral up to 277,000. And then just figure out where I am, right? But I feel the need to, like, find the beautiful pattern. So what's the beautiful pattern? So I know if the number is a square, like if it's a perfect square, then that's easy. I can answer that. Can I just find the closest perfect square and use that to determine what I need to determine? Like, so 26, it's going to be right here, and that's going to add just 1. But 27's going to subtract 1. And 28's going to be 1 even lower. So it's got this sort of, you know, peaks and valleys sort of pattern if you were to draw the function out. I think the secret sauce here is just figuring out what the coordinates of each of the perfect squares are, and then find the closest perfect square and walk to it in order to find the coordinates. I think that's the elegant solution here. So, like, for instance, I would, let's see. So the closest perfect square is, square root. Is that in the math library in Python, or is that in the global namespace? Yeah, that's what I thought. I'm pulling in NumPy. So take the square root of the number and then take the floor of it. Well, 1925 gives me, like, this spine right here, but there's, like, another spine that's going up this direction that's going to be 4, 16, 36, and so on. So you can base it off of those, too. It could be closer to the next square instead of the lesser square, but I don't need it to be the closest one. I just need a frame of reference. Because the alternative here, and almost certainly the intended solution, is first for me to turn down the music. But almost certainly the intended solution is for me to just, like, enumerate it. If the square root is odd, then I have the idea then. Yeah. Yeah, 49 will be down here, and then after that, 81, and then after that, 121. How much input do I actually want here? I don't know, I'm feeling it out. I mostly prefer to solve these on my own. I don't necessarily want to be aided, even if I'm going down a bad path. But sometimes I'm going to talk through my solution, and who knows what I want then. I mean, I don't have a problem with people talking about, I don't know. If y'all want to talk about, like, cool ways you'd solve the problem, that's fine. I'm almost certainly over-engineering this. No, you're good. This isn't going to print anything meaningful. I just kind of want to do this. That seems to be doing what I intend it to do. I mean, my ultimate goal is just to get a frame of reference. Right? So, like, if I can just identify, like, I already know where 25 is located on the board, and I'm at 40, where is 25 related to 40? Right? If I can do that math, then, like, the solution ends up being relatively trivial from there. I mean, the perfect solution would be a function that converts any number to its coordinate system in this spiral. And I'm certain that one exists. I'm absolutely certain. I just don't see the natural, elegant solution popping out at me. So I'm kind of just trying to work backwards. This is by God, a trivial problem. If I just implement it the way they wanted me to, which is I count up from 1 and I just like walk around the spiral with some counters. Like, it's so trivial. It's day 3 because they did not expect anyone to be over-engineering the day 3 problem, but I'm just fascinated by this one. Sorry, I'm just braining for a moment. Oh, y'all don't want to get me off on IQ tests, I promise. No one will enjoy that conversation, not even me. Just how quickly you solve the problem. There's a timer countdown to when the next problem releases, so you can see how quickly they were solved. Okay, so I'm doing a little cheating here. I'm aligning it to the wrong one. I'm aligning it to the wrong one. Wait. Where am I at right now? Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. So all of these are correct. Okay, wait. All of these are correct. This is fine. This is good. I think I'm on the right track now with what I want to achieve. Math doesn't click for some people, and that's fine. I think this is starting to give me what I want. And so from here, what I want to do is Uh... I guess I need a bailout right at the start. So what are the coordinates of that location, right? So if I see that it's 1, then my origin is it's closest -1 divided by 2. Okay, so that'll tell me this location right here. So 9 will be marked as 2 divided by 2 is 1, so 1, 1. 11 is 2, yes, but we have work to go. Pip installs spiral memory. I swear to God, I would be so upset if that were a real thing. If, n equals closest, return origin. Really don't want to do this with a tuple. I'm going to be, like, modifying it as I go. Can I be just a little more clever than that? Can I be just a little more clever than a tuple? I mean, I could just make a simple point class, I guess. Fine. Okay, so now I'm just, like, iterating at this point like a dumbass. Again, reminder, like, I'm knowingly over-engineering this. Don't sweat it. Hold on. Wait a second. This is 49, 50, 51, 52. So 52 were right here. Hold on. If you needed to go the other direction, this would be trivial. I feel pretty confident I could write the mapping in the other direction. All I wanted to do... God. I'm gonna sit here for like an hour on day 3 puzzle because I'm trying to over-engineer this dumbass problem. Yeah, of course it does. There's modular right there. I'm like fascinated by the over-engineering I'm doing here. This is truly something special. No, my code is cringe. It's like, this is extremely close to a working solution, but it's still not like... Okay, so here's my problem with it, is that it's not... Ah, fuck it. I can write some really crappy code right now and be done with this, so let's do that. So there's 1, 2, 3, 4 arms I need to do here. So for I in range 4, if n is less than... I kind of want to weirdly position myself in a strange place here. Hold on. This is kind of... It doesn't make a lot of sense yet, but I think the math will check out. So, like, if you visually think about what this is doing, it's bad. But if you don't visually... Hey, if you don't think about what it's doing, and instead accept that I have to be right, I think this is going to work. So if I'm at 9, for instance, so I'm at 1, 1. I'm now looking from this position. This is so stupidly over-engineered. I hate this. What's the arm length on each of these? So if I'm at 9, the arm length is 4. If I'm at 1, the arm length is 2. Next one would be 6. It's this D value. Plus 1 times 2. V plus Z. God damn it. I'm like annoyed at the over-engineering, but I've committed. I guess there's a smarter way to write this. Val is less than or equal to n plus z. Yeah. Then what I really want is I want point dot x plus equals dx times... Christ. Val minus n? The reality is that this is going to find the answer in constant time. The problem is that I don't need to find the answer in constant time. That is not necessary for this. I think this works. I do. Perfect, exactly. That's what I thought. Which one does it use? Does it use Repper? Okay, well, we were close. Manhattan distance is just taxi cab distance. If you need to get from one block to another, how many street lengths do you need to go? I know I'm on the right track, I just gotta figure out how to fix this. Because this should have been 1, 0, and this should have been 1, -1. So what did I do wrong? Is this subtraction backwards? One 0, 1 -1. Oh, sweetie, no. this inequality is incorrect. Let me think about it for a moment. What I'm trying to say is that if it's not along, if it is along this leg, to only go partway down, right? So I need this if statement to capture the scenario where I'm only going partway down this leg. And that happens when the value that I'm currently at plus the leg length, if n is less than or equal to the value I'm currently at plus the leg length, right? Okay, so the way I wrote it the first time was correct, and I was just a dumbass to change it. Sorry, I don't know why I'm like being weirdly self-deprecating. That's a simple mistake to make. Okay, so let's confirm it with a few known values. 23 should be 2. Yep. 12 should be 3. Yep. 1 should be 0. Okay, cool. That worked. That was fun. Can't wait to have to savage all of this code once it changes the rules on me. As a stress test on the system, the programs here clear the grid and then store the value 1 in square 1. Then, in the same allocation order as shown above, they store the sum of the values in all adjacent squares. Very good. Oh, Lord. Okay, this one you actually do have to simulate. You're just not getting around that, are you? Huh. Interesting. Alright, I mean, I can think of an elegant way to implement this, but first half of this was a way more interesting problem. I have to do them in order, though. Python's just comfortable for me. I know the tools readily. I don't know. I mean, I could reasonably implement this in a number of languages, but Python just has a lot of tools I'm really comfortable with. See, if I had code from the previous section where I actually iterated the spiral, I'd have half of it written already. But now I actually have to write that code this time. So... Damn, Felix. Hold on, I'm just... Oh, couldn't I do that? Yeah, I think you're right. Yeah, I guess I could. I guess I can reuse a lot of that code. Would certainly be less of a pain. It's not going to be actually quite as efficient, but it's not going to be a big deal. Does that just work? Oh, his default dict with lowercase. Alright. We got there. New system policy has been put in place that requires all accounts to use a passphrase instead of simply a password. Passphrase consists of a series of words, lowercase letters, separated by spaces. To ensure security, a valid passphrase must contain no duplicate words. That one's not hard. My editor did not like me pasting all that in. I was like, oh no, I have to highlight all this? That sucks. Yep, I've used a set before, thanks. No two words that are anagrams of each other. Okay. What? Oh, do I have to, like... Is it doing a weird thing for them? Unhashable type list? Oh, it's because I'm not turning it back into a string. Duh. Yeah, I mean, I guess I should... What's the value of me doing this if I don't talk at all about my solutions? So Since it wanted to check to see if they were anagrams, sorting two words will easily identify if they're anagrams, so that's all I did. In order to check to see whether or not they were all unique words, since sets in Python can't have duplicates, since they implement the actual concept of a mathematical set. If I if I just throw all of the items in that list into a set, it'll remove the duplicates for me, so. So if I throw all the words from a passphrase into a set and their lengths are the same, the original and the new one, then that meant that there were no duplicates. Nothing got crunched. So you could do this in a different way if you didn't have sets available to you, if you weren't comfortable with doing it this way. So this is a set comprehension in Python. This is technically a list comprehension in Python too. I'm doing a whole bunch of nonsense as I go. But if you didn't have sets available to you, what you could do in exchange is you could sort the list of words alphabetically and check to see now whether or not, because now if you sort the list alphabetically, you'll be able to easily identify whether or not there's any duplicates because they'll now be right next to each other. So that's another approach you could take if you wanted to. Sorting tends to be, I mean, I don't want to give away any secrets, but like if you're doing problem solving in computer science, sorting is like the solution to about 70 to 80% of problems. If you just sort, it gets you pretty far. An urgent interrupt arrives from the CPU. Message includes a list of the offsets for each jump. Jumps are relative. -1 moves to the previous instruction, 2 skips the next one. Start at the first instruction in the list. The goal is to follow the jumps until one leads outside the list. In addition, these instructions are a little strange. After each jump, the offset of that instruction increases by 1. So if you come across an offset of 3, you would move 3 instructions forward, but you would change it to a 4 for the next time it's encountered. Okay, cool problem. This is a classic type of simulation problem. Yep, that's how I did the anagrams, is I just sorted all of the passphrases coming in. Alright, so there's all my jumps. Next is 0, while true. Steps is 0. While index is greater than or equal to 0, and index is less than length of jumps. Let me cache that. I'm sure Python's smart enough to cache that for me, but yeah. Sorry, my font is a little small, isn't it? I'm sorry. I've been doing this all at a really small font. I usually increase it for this. I apologize. That's just the size my font usually is on my screen. I completely forgot to do that. I almost always increase the font size when I stream coding. Do stuff and then print steps. So all I gotta do is look at the value at that index. Next equals index plus whatever's at that location. So jumps index. Jumps at index plus equals 1. And then index equals next. I can't really make this any larger. Or rather, the ways that I can do it, I do not choose to. Oh, I hit the... This is why you just copy and paste it. I don't know why I was like, oh, I'll type it. Well, they don't want you to just brute force solve problems, right? Especially with there being a leaderboard, they don't want someone to write a script that just submits, you know, the first 1 million integers trying to brute force the right solution. I accept your abbreviation of index as IDX. I also consider it to be wrong. No offense to you personally. I's fine, I just don't prefer it when I'm not using it as a control variable in like a for loop. I'm just razzing you, Planeswater. I think I've seen IDX a bunch of times before too. Now the jumps are even stranger. If the offset was 3 or more, decrease it by 1. Otherwise, increase it by 1 as before. So it's just that. This is it. This is the only change. Really? Alright, it's Monkey Island. Really? Why would you make that the part 2? Wait, did I not save it? I didn't save it. Oh, is this... Oh, did I fuck up? Actually, did I fuck up? There's no way that's right. That's a big number. This is just Rainwave. I'm listening to the OC remix on Rainwave. There's no way this is right. No, you're thinking of either what's the name of those websites? There's a few competitive programming websites that all the code geeks use. What is the ones? LeetCoder is one of them, but that's not the one I was thinking of. HackerRank. I think that's the one I was trying to think of. I've never used any of those sites, despite being into competitive programming. I'm just not... I don't have the... energy to measure myself. Debugger program here is having an issue. It's trying to repair a memory reallocation routine, but it keeps getting stuck in an infinite loop. In this area, there are 16 memory banks. Each memory bank can hold a number of blocks. The goal of the reallocation routine is to balance the blocks between the memory banks. The reallocation routine operates in cycles. In each cycle, it finds the memory bank with the most blocks, redistributes those blocks among the banks. To do this, it removes all the blocks from the selected bank, and then moves to the next index, and inserts one of the blocks. It continues doing this until it runs out of blocks. If it reaches the last memory bank, it wraps around to the first one. Debugger would like to know how many redistributions can be done before a blocks in bank configuration is produced that has been seen before. I understand the pattern, I'm just trying to think of how I'm going to implement this efficiently. If Python will let me turn this into a tuple, I can use a set to determine whether or not I've seen a state before, but that's a little clumsy. Making sure those are tabs. Yep. Probably Super Metroid. I mean, they are contrived. This is pretty standard for... I mean, this is pretty standard fare for competitive programming, though. Competitive programming very much tends to start from a place of, like, here is a puzzle I want solved, and then I need to come up with a story to go around it. How am I ripping the input so fast? Oh, I'm just copying and pasting. I'm not, like, reading it from any special... I'm just copying it in there, and then this is just a list comprehension that splits it on the tabs and converts them all to ints. I mean, the long and short of it is that if a programming problem said implement a time-dependent dynamic shortest path solution, like, that's not interesting. But if someone tells you, okay, you've got this network of roads in a city, and the city shuts down roads based on this pattern, can you find a shortest path starting at 3 o'clock from this location to some other location? And, like, the idea is that you should be able to recognize, oh, that is a time-dependent dynamic shortest path problem. Hey, Double Donut, thank you so much for the resub. I don't think that this problem is terribly hard. Nope.
Everything going alright?
Mm-hmm.
You doing a programming stream?
Yeah.
Cool. Got a third run underestimate again, so that's good.
Way to go. Flaps bad, thanks so much for the sub, the prime sub. I mean, this is, for the most part, a simulation problem. A lot of these problems, I'll be honest, are a little easier. I mean, I'll still get hung up on plenty of them along the way. I'm not trying to say, like, this is all easy problems, but these problems tend to not drift into the, like, highly theoretical, demanding a lot of sophisticated algorithms. A lot of these problems can be done through relatively rudimentary simulation, and this is just a simulation problem. So all I need to do is simulate a step, and then confirm that it's not a revisited state, and then simulate a step, and then confirm it's not a revisited state, and so on. Not brute force. Simulation usually refers to you're being given a process, and rather than trying to like zoom out from the process and figure out some sort of like elegant way to do it faster, you just do the process it tells you. So here it's explaining to me how I can redistribute data among different banks. And rather than trying to get too sophisticated and figuring out, okay, based on this input, the answer is 6. I'm just gonna do the thing it tells me to do and count how many steps it takes. I'm simulating the process. No, and I think what you are, I think Tuppen seen is probably the right way to write that. I think has is from something else. I don't know. My brain is gelatin. I'm not even sure there is a has function in Python, is there? Python sets... Let me look it up real quick. Let me embarrass myself. Python sets. No, there's no has. I'm brain dead. Has is from something else, I don't know. Well, I don't need to get it. I just need to know if it's in there. And there's no get method for sets. Sets are purely for identifying membership. I mean, Python's great for dealing with JSON objects. JavaScript's great at dealing with JSON objects, but that's really cheating. I feel like if you say that Python or that JavaScript's great at dealing with JSON objects, I feel like that's cheating. Yeah, I'm using in now. There is a faster way to do this. This is not the fastest way to do this right here. But the right way to do this, I don't want to do. There you go. There's my answer. I don't owe anyone a better one. What? Oh. Would like to know the size of the loop. Starting from a state that has already been seen. Well, I mean, that's not a hard change. I might have an off by 1 here. Never mind. I'm a genius. The only change I had to make is I had to tell it what loop I found each thing, so I changed it to a dictionary rather than a set. Wandering further through circuits of the computer, you come across a tower of programs that have gotten themselves into a bit of trouble. A recursive algorithm has gotten out of hand, and they're balanced precariously in a large tower. One program at the bottom supports the entire tower, holding a large disk. And on the disk are balanced several more sub-towers. At the bottom of these sub-towers, standing on the bottom disk, are the other programs, each holding their own disk, and so on. At the very tops of these sub-towers. I'm sorry, I got distracted and started thinking, is this Towers of Hanoi, and then stopped listening to myself read out loud. Let me go back for a second. The song is up in the top left of the screen. This is like mostly a parsing problem, right? this is like 90% a parsing problem. All you gotta do is look at all the names on the left and all the names on the right, and you find the one on the left that's not on the right. That's it. You don't have to make the tree at all. Make a set of the left, make a set of the right, subtract. The convenience of that solution will come crashing back down on top of me when the second half of the problem wants me to actually do something. But in the meantime, we're feeling pretty good. Okay, here's the part of every advent of code where I have to take a quick breather and convince myself that it's not embarrassing to just do this with string parsing. It's okay to not write a regular expression if you don't want to. Nobody actually wants to write regular expressions. People who do want to write regular expressions are fooling themselves, and everyone agrees that it's better to just split on strings. I appreciate y'all. I appreciate how much energy y'all are putting into convincing yourselves of these things. I think that's good. I think that's actually good if you think about it. I'm not going to write regular expressions. So stupid. Who would write a regular expression? Oh my god, what are my hands doing? I can't stop myself. I don't feel like writing the conditional part of it. You can get bent. Isn't this the way it used to work in Python, that you could just write that way? Did they make me write better syntax now? Oh, right. Yeah, just a silly typo. Still don't like that, huh? Alright. No, I get it. I get it. Don't let me get in the way. Can I just unpack the groups really easily? I forget how I can use groups to do this. Yeah. Pretty sure this is going to give me a key error instead of doing the thing I want it to. Right? That's going to give me a key error. That's what I thought. There. No other way around. Oh. Am I parsing this badly? Oh, that's getting the list of parents. Programs explain the situation. They can't get down. Oh no, they can't get down. Oh, okay, can't get down. Got it. They could get down if they weren't expending all their energy trying to keep the tower balanced. Apparently, one program has the wrong weight, and until it's fixed, they're stuck here. For any programming holding a disk, each program standing on that disk forms a subtower. For any program holding a disk, each program standing on that disk forms a subtower. Each of those subtowers are supposed to be the same weight, or the disk itself isn't balanced. The weight of a tower is the sum of the weights of the programs in that tower. Oh no, I actually did make the tree. By keeping a list of parentage, that gives me the whole tree. I did more work than I needed to do. I can flip this, though. That might actually be the better way to do this, is to keep a child set instead. Yeah, the solution where I kept track of the parent set made sense for the first half, but it doesn't make sense for the second half, so flipping it makes sense here. I can disregard any of them that have only 2 children, right? Can I? Because, like, there's no way to figure out which one it's going to be with only 2 children. Like, which one is wrong? So it's got to be one of them that has a number of children that's 3 or more. I don't know what this is going to print out. I just kind of want to see where I'm at. Am I using map correctly? Oh, okay, so the weird way that I did this messed me up. Got it. Okay, so the error's coming from here. So I'm going to hit multiple ones this way. I'm looking for the baseline one. Looking for the deepest one. Yeah, that's something I hadn't really thought about, is the fact that if one of them is quote-unquote wrong, it may very well be wrong at multiple levels, and I need to take that into account. So... Okay, so that's where my issue is. I mean, it's just 2096. I don't have to do all this extra math at this point. Oh, wait. Oh, it's the other way around. It's 2090. I wasn't trying to brute force it. I guess I could have, like, confirmed that by just looking at the map. Yeah, 2090 is what I should have had. If that's not the right answer? Why is that not the right answer? Wouldn't changing that one's weight fix it all? I mean, I guess I can confirm that, right? If I changed this one... Doesn't that just fix it? Do you have children that you're not telling me about, my man? I mean, I can, at this point, I can start to hammer on it and brute force it if I want to, but I'd really rather not. Who are your children, my dude? Oh, you do have children, don't you? But they're all the right weight. I mean, I know how I could produce the right answer right this second. I want to write a program that gives me the right answer. I don't like this way of doing this. I'm just trying to find the odd one out. Is there, like, an elegant way to do that I'm just missing that's obvious? I feel like there probably is. I'm trying to come up with a clever way to do this. Not clever, but like, what's the most elegant way to pick the one element out? The one element that's unlike the others. I mean, I could sort it based on the key, but... Is that gonna work? Okay, that did give me the odd one out. You ever just write bad code on purpose? That's sick. That's sick. Yo, same. Yo, Loon, thanks for the raid. Take it easy, Carrie. Bizarre problem. I'm glad to be done with it. You receive a signal directly from the CPU because of your recent assistance with jump instructions. It would like you to compute the result of a series of unusual register instructions. Each instruction consists of several parts: the register to modify, whether to increase or decrease that register's value, the amount by which to increase or decrease it, and a condition. If the condition fails, skip the instruction without modifying the register. The registers all start at 0. The instructions look like this. Okay, got it. I'm gonna run it on this test input first before I do anything else. Okay. Oh, my life is going to be a hell of a lot easier if I don't do this. I don't know why I'm doing this. Pardon me, sorry. I'm just trying to make this as easy for myself as possible to write. Doesn't Python 3 have a match thing going on? When did they... Oh, it's Python 3.10. Ugh. Thanks for nothing. I can consolidate some of this code down, and I would like to. Because technically, it's gonna try every branch, and I don't want it to. Oh, I had a typo in here anyway. So I probably saved myself some headache by looking at it a second time. One. Okay. I'm gonna trust that that means I did perfectly. Is it? I'm sorry, are you sure? I don't know why I had to do that. Why does it let me use... Like, honest question, maybe it's something I don't understand about Python. Why is register, like this variable right here, it didn't care about that, but for an integer it does? Because I assign. Oh, and it instantly gets a local scope here because I assign it? Like it's hoisting that knowledge? Wait, really? Is that what it is? Like it recognizes there's an assignment in here, so it hoists MX to be some sort of like local only? That's weird. I hate that. That's bad. I've never run into that before. That's really funny to me. Yeah, that's obnoxious. That scoping should only happen when you define a variable on the inside. But I mean, I guess that's kind of what's happening there. Yeah, I guess I understand. I guess I understand. Yeah. Yeah, sure. Okay. Okay, yeah. I get that. I do like stronger typing personally, but hey, now's neither the time nor the place. A large stream blocks my path. Hold on, let me check that. No, I do not see a stream blocking my path. It's not safe to cross the stream at the moment because it's full of garbage. You look down at the stream. Rather than water, you discover it's a stream of characters. You sit for a while and record part of the stream. The characters represent groups, sequences that begin with curly brace and end with a curly brace. Within a group, there are 0 or more other things separated by commas. Either another group or garbage. Since groups can contain other groups, a curly brace only closes the most recently opened unclosed group. Yeah, sure. That is, they are nestable. Your puzzle input represents a single large group, which itself contains many smaller ones. Sometimes, instead of a group, you'll find garbage. Garbage begins with an open angle bracket and ends with a close angle bracket. Between those angle brackets, almost any character can appear, including curly braces. Within garbage, open square bracket, has no meaning. In a futile attempt to clean up the garbage, some program has canceled some of the characters within it using an exclamation point. Inside garbage, any character that comes after exclamation point should be ignored, including angle brackets and even another exclamation. So the score is its nesting level. Mm-hmm. No, yeah, for sure. Yep. Cool. This'll... Well, let me find a good one to test with. I guess this'll probably be... This'll probably be my best weird one to test with. Weird parsing. So the highest precedence thing to be on the lookout for is an exclamation point. Because no matter what, it wins, right? That's fine, I don't need to qualify that in any way. Can't wait for the part where it wants me to check for malformed input. I feel like there's a more elegant way to write this. I was dead. What would such a thing entail? I'm not going to compete with my friends at programming. First off, most of my friends would clobber me at programming quickly. And second, I don't know. This is relaxing for me. And this was supposed to produce a 3. I mean, worst that could happen is that it doesn't work on this input, right? I don't actually have high confidence in this parser. But it was the right answer, so I'm a genius. Now you're ready to remove the like. Fuck I am. No, I don't love that. Is it just... Maybe this is actually trivial. Hold on. Not the right answer. Okay. That's supposed to give me 2. This should give me 10. That gave me 8. Okay. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so what am I not counting here? Oh, I'm capturing the opens here. The way that I wrote that initially actually lent itself okay to being able to count the garbage characters. So I was surprised that it didn't match it right away, but it's just because I was capturing the open angle brackets in a weird spot. I had, like, ignored the fact, I was like, oh, if I run into an open angle bracket, setting it to true again doesn't hurt anything, and I forgot that that was mean I wasn't falling through to the else. I could have also, alternatively, left it alone and just added another G count here, so... Not hash. You come across some programs that are trying to implement a software emulation of a hash based on knot tying. Actually, knot tying algorithms are really fascinating. The hash these programs are implementing isn't very strong, but you decide to help them anyway. You make mental note to remind the elves later not to invent their own cryptographic functions. Hey, let me take a moment to remind all of you not to ever implement your own cryptographic functions. I assure you, you won't write them very well. Actually, you know what? There's like a handful of you in this chat who don't need that warning. You'll write them just fine. But for the rest, if you don't do it... This hash function simulates tying a knot in a circle of string with 256 marks on it based on the input to be hashed. The function repeatedly selects a span of string, brings the ends together, and gives the span a half twist to reverse the order of the marks within it. After doing this many times, the order of the marks is used to build the resulting hash. Current position, which begins at 0. Okay, I'm following. Okay, I've got some ideas about how to do this properly. I mean, I guess I could just... Yeah, it definitely has more to do with not accounting for ways that you can make mistakes rather than, like, a convenience. It's not like someone's already... It's not like, hey, someone already invented a good cryptographic function, don't waste your time. It's more like, if you do it, you could very well produce something very bad. Something that could be terrible for what you're trying to do. I have a clever-ish solution for how to kind of get around one of the limitations here in Python, but it occurs to me that it's going to make producing the result difficult. Because, I mean, obviously one of the issues here is that reversing a sequence or subsequence that's kind of circular in this way is challenging, I guess. And so you could just like shift the whole thing. You could shift the whole thing and then shift it back afterwards, I guess is the answer. I mean, it's just a simulation problem. There's really no reason to get super sophisticated on this one, right? We're not to like day 18 where a bad solution will not terminate before the inevitable heat death of the universe. Trying to think of what my game plan is here. Let me confirm that I'm getting the same answer as them on this first. Well, it starts at 0 if you want to add ahead of time. It starts at 1 if you want to add after. Right? Unless I'm misunderstanding something. By the length plus the skip size. Okay, that's the part I was misunderstanding. Got it. How old is this song on OC Remix? I swear to God, I had this on like my iPod 20 years ago. Posted in 2001. Holy shit. I distinctly remember listening to this one when I was in high school. I need to think for a second. I'm trying to do some really stupid thing to avoid having to write this the more annoying way to me. I'm trying to rotate it by exactly this amount, so I want just the end plus everything up to the adjusted point. Can I just do this? What? 34210, that's correct. chose to do this a very stupid way, and now I'm having to debug a very stupid way. Okay, maybe my very dumb way of doing this was not a good idea. Wait. That still didn't fix it. Okay. I mean, I can do this the way I'm supposed to. I'm just... I'm ultimately avoiding just doing this the right way, and that's what's punishing me. I think I just have to implement it as intended. That wasn't that hard. I don't know why I worked so hard against that idea. The logic you've constructed forms a single round of the not hash algorithm. Running the full thing requires many of these rounds. Some input and processing is also required. It's just tuple packing and unpacking. I mean, there's nothing really magic going on in Python there. Jesus. Yeah, this is a pretty extra one. Lovely. Mm-hmm. Oh, I'm sure this hex method has a way to get rid of the 0x at the beginning of everything, but I gave up on caring.